All right. Shortly after introduction of the euro coin in Belgium, newspapers around the world published articles claiming the coin is biased. The stories were based on reports that someone had spun the coin 250 times and got 140 heads. That's 56%. Do you think this evidence that spinning a euro is unfair?
No, it's just one person spinning it.
No, you can try and multiple or increase the number of trials. See that?
Okay, so we're gonna, do math to see. So we could use binomial, but for the sake of this, we're gonna do normal, just because it's gonna be a little better, and it's easier to use. So first and foremost, we will always check our conditions. So NP is greater than 10 and NQ is greater than 10. Because we had 140 heads and 110 tails, and both of those are greater than 10. So our sample size is large enough. Then the independents are 10% condition. All right, is it independent?
Yeah.
Yes.
Yes, because one doesn't affect the next one.
I have a question. What would be an example again of a dependent scenario?
Like where there's like not any replacement.
Well, where like one thing, like yeah, like if you had like a deck of cards and you pull one and you keep it out, because then it changes the probability of the next one. So basically, if like the probability of it stays the same throughout, then it's independent. All right, so we're going to look at the mean and standard deviation. So mu is equal to n times p, which is 250 times. This is the probability that it should be, okay? So p is going to be 0.5. Because in theory, we should get 50% heads, 50% tails. So that's 125. Then standard deviation is the square root of NPQ. Square root of 250 times 0.5 times 0.5. And that should be 7.91. So we're going to look at the normal model of 125 and 7.91. Okay, so that's just the mean and standard deviation for how we write our normal model. So I'm going to look at z-score of x minus mu over sigma. So 140 is what they got, minus the mean is 125 over standard deviation is 7.91. Y'all tell me what that is. So we're looking at, in terms of the model, the mean is here in the middle. They got 140. And they said that basically they think that that's like unfair. So we're trying to find the probability that it's greater than 140. So we're going to look at the probability of Z being greater than 1.90. And so from your tables, which you probably don't have handy. Maybe you do. I don't know. Man down. 1.90. So 1.90 is 0.9713. But what is that number?
That's everything to the left.
That's to the left, so how do I need to find what I'm actually looking for?
1 minus.
Yep. 1 minus 0.9713.
Point 0.028.
So that's a pretty low probability, right?
Mm-hmm.
But it's not like really, really low. So the probability of 140 heads is low, but not too low. So it could be unfair. Now, I would say they need to probably flip it more than 250 times, and 56% heads is,
I feel like that's close enough.
yeah. Because we know that the more you flip it, the closer to 50 it should be.
Mm-hmm.
Right.
So unless it's like weighted weird or something,
Yeah.
then that's the only issue. All right. Vitamin D is essential for strong, healthy bones. Research shows that about 20% of British children are deficient in vitamin D. Suppose doctors test a group of elementary school children.
About teeth?
Yeah.
No.
What's the probability that the first vitamin D deficient child is the 8th one?
Or was that like
So would you have to do point
Eight, so it's-
0.8
Has to be a certain
to
number.
the 7th times 0.2?
Yep. So 7 that aren't deficient and then 1 that is.
0.042?
What's the probability that the first 10 children are all okay?
So is that like 0.8 to the 10th?
Yep.
0.12. I mean 0.11.
How many children do they expect to test before finding one who has this vitamin deficiency?
Wait, how do we do that?
So like find the average.
The expected value.
I
The
guess
formula
it'll
for
be like-
expected value.
Oh,
5.
I gotta. That's not formula. Okay.
What's the formula?
Ex equals u. Or is that
Well, yes, that's the same thing.
1 over p?
Yes, 1 over p. So this is 1 over 0.2. So how many children is that?
5.
They will test 50 students at the 3rd grade level. Find the mean and standard deviation of the number who may be deficient in vitamin D. So with this one, mu is equal to
NP.
NP.
So would it be 50 times
0.2.
the 0.2?
Yeah. So it's 10 children. Then standard deviation. What's the formula for that?
Square root of NP cubed.
Okay, so square root of 50 times 0.2 times 0.8. How many children?
8. Root 8. I guess. Keep on forgetting about the root.
I was like, it can't be 8.
Numbers. 2.83. There we go.
Okay, 2.83 children. If they test 320 children at this school, what's the probability that no more than 50 of them have have the vitamin deficiency? This one can be done on the calculator.
Also, do we have to
Which function do you think we need?
I'm gonna go for binom CDF
Binom CDF. Why did you pick that one?
because isn't that one the one where order doesn't matter?
Correct. Order does not matter, so it's binom.
Adding them all together type thing, but it's
Yep, add them up. So 320, 0.2, and 50.
So would that be the same as doing like the what is it, NCR thing?
Yes. For 320 things taken 50 at a time.
Yeah, that would be awful to write out.
Yeah.
0.027.
Now, let's back up because I can also do A and B on my calculator.
Sure. Yeah.
What would I have now? Obviously, I would just do this one by hand because it's much easier. But what would I need to be able to get number 1 or A?
Geometric PDF.
Yep, geometric PDF. And it would be of 0.2 and 8. What's the probability that the first 10 children are all okay? Which one would that be?
Geometric CDF.
Yep. Geometric CDF of 0.2 and 10, but it's actually going to be 1 minus that. Because this is they all have a problem. And we want them to all be okay, so it's going to be 1 minus that. All right. Do y'all just have 1 page left? Okay, well, there were still 2. I was really confused. I was like, I only see 1 on my thingy. I was a little worried. All right. The American Red Cross says that about 11% of the U.S. population has type B blood. A blood drive is being held at your school. How many blood donors should the American Red Cross expect to collect from until they get a donor with type B blood?
Will you be expected value from
Yep.
So it would just be like 1/.11.
Yep.
9.09.
You sound so
9.09 people.
That's a really tiny person.
It's the person that's only as tall as the light socket. Or that's outlet, I guess. What's the probability that the 10th blood donor is the first donor with type B blood?
Okay, so we have like 0.89, like 9, and then we have 0.11, multiplying those.
How could I do this on the calculator? What function? Yep, geometric PDF. Why'd we choose geometric?
because it has an order.
Yep.
Yeah,
Order matters. And PDF because we're looking for in a specific spot. So what did we get?
so 0.039.
All right. What is the probability that exactly 2 of the first 20 blood donors have type B blood?
Would that be like do we want the NCR thing for that?
Yep. Oh, I would probably actually use my calculator instead of having to write everything out, but we're going to write that out so you see it as well.
Like if we were to do like a calculator thing, would that be like binom CDF?
PDF.
CDF?
Because it's exactly.
Yeah, it's
Yeah.
exactly 2. So order doesn't matter, but we need 2 of the first 20, so that's why it's got to be exactly that amount. So this would be, if we wrote it out, 20C2, so 20 people taking 2 at a time, of 0.11 squared times 0.89 to the 18th, or binom PDF of 20.11 and 2. Did you get a number, Josh?
0.28.
Almost done. What's the probability that at least 2 of the first 10 blood donors has type B blood?
Would that make it CDF?
Yep.
At least?
And we still don't care about order, right?
But yeah, it
So
would still be
binom. Now, at least makes us think what?
1 minus.
1 minus.
Yep. So 1 minus the probability of 0 or 1, which would be 1 minus if we wanted to do it by hand, which again, I would not do this one by hand, but 10C0, 0.89 to the 10th, plus 10C1 of 0.11 times 0.89 to the 9th. I would do instead 1 minus binom CDF of 10.11 and 1. but you can do whatever you prefer. Did you do 1 minus?
Well, 0.30.
I was like, I was expecting a smaller number.
Yeah, I forgot the 1 minus.
All right. The blood drive has a total of 150 donors. Assuming this is a typical number of donors for a school blood drive, what would the mean and standard deviation of the number of donors who have type B blood be? So this one is N times P, so 150 times 0.11. 16.5 people with type B blood. And standard deviation, square root of 150 times 0.11 times 0.89. Josh, don't forget the square root this time.
Both Joshes like
I'm
to
just
do
gonna
that.
put this in
Yeah.
the calculator this time so I don't call out the multiplication part. 3.383.
3.3? Oh. I was like, people with type B. Surprised by the low number of type B blood donors at the blood drive, the American Red Cross wonders if the 11% estimate was too high for your area. How many type B blood donors would it take to convince you that the estimate might be too high? So N times P and N times Q are both greater than 10. The 10% condition is 150 people, less than 10% of the population.
Yeah, I guess.
Yes, and each person's also independent, right? One doesn't affect the other, so. So we know there are 16.5 people with type B blood, meaning that out of that 150, 133.5 did not have type B. So I'm going to use this mean and standard deviation to create a normal model. Okay, and then I'm going to see what would be considered unusual.
Yeah. So like, did maybe one of these people have like type A, B, so that's why they're just half type B?
Mary.
I don't know about all that, but. Now, for simplicity's sake, I'm going to call that standard deviation 4 so that I'm not doing 0.83s. So I'm going to have 20.5, 24.5, and 28.5, and then going down 12.5, 8.5, and 4.5. All right, so how many type B blood donors would it take to convince you that this estimate might be too high? Like, basically, what do we consider unusual?
Like 2 standard deviations.
So,
Like,
essentially,
8.5,
huh?
like less than 8.5.
Yeah, so we would say if we saw less than, rounded up 9 people, then we would be thinking that there's probably too high. Because we can't have a half a person when it actually comes to that. If we saw less than 9 people, it could be considered too high. I'm gonna see if I can find a funny clip about a half a person and show it to you.